IET NCERT presents audiobook of mathematics for class 5 entitled MATHMAGIC 5. This is the chapter 6.
Part 1.
Page 87. Be my multiple, I'll be your factor. The mouse and the cat. To the right side of the page, we see a long picture in which there are a number of steps on which we see a mouse and a cat. The cat is trying to catch the mouse coming downwards. The text to the left of the picture explains everything else. The hungry cat is trying to catch Kunjan the mouse. Kunjan is now on the 14th step and it can jump 2 steps at a time. The cat is on the 3rd step. She can jump 3 steps at a time. If the mouse reaches 28, it can hide in the hole. Find out whether the mouse can get away safely. A. The steps on which the mouse jumps. Dash. B. The steps on which the cat jumps. Dash. C. The steps on which both the cat and the mouse jump. Dash. D. Can the mouse get away? Find out. If the cat starts from the 5th step and jumps 5 steps at a time, and the mouse starts from the 8th step and jumps 4 steps at a time, can the mouse get away? For the teacher. Children should be encouraged to make similar questions with different multiples and ask each other to solve. Page 88. Who is Monto waiting for? Monto Cat is waiting for somebody. Do you know for whom he is waiting? There is a trick to find out. There's a picture below this, in which to the right side we see Monto Cat on the shoulder of a girl. Below that we see lots of number stickers. There are some letters from the English alphabet written randomly all over. Mark with a red dot all the numbers which can be divided by 2. Mark a yellow dot on the numbers which can be divided by 3 and a blue dot on the numbers which can be divided by 4. Which are the boxes which have dots of all 3 colors? What are the letters on top of those boxes? Write those letters below in order. There is a blank box provided for your answer. Page 89. Meow game. To play this game, everyone stands in a circle. One player calls out 1, the next player says 2, and so on. A player who has to call out 3 or a number which can be divided by 3 has to say meow instead of the number. One who forgets to say meow is out of the game. The last player left is the winner. To the right side of the page we see a picture of a group of children playing this game. One boy seems to have missed meow. Which numbers did you replace with meow? 3, 6, 9, dash. We say these numbers are the multiples of 3. Play the game by changing the number to 4. Now, which numbers did you replace with meow? These numbers are the multiples of 4. Write any 10 multiples of 5. There is a blank box provided for your answer. For the teacher. Make children play this game several times with multiples of different numbers. Page 90. Dice game. Throw 2 dice together. What are the numbers that turn up on the faces of the dice? Make a 2-digit number using them. If it is a multiple of any of the numbers written next to the circles, you can write it in that circle. Then it is your friend's turn. The one who can write more numbers in 10 rounds is the winner. To the right side of the text we see a boy throwing 2 dice, playing happily. Below that, we have a conversation between a boy and a girl. The girl is saying, "I have 3 and 2 on my dice. If I make 23, it is not the multiple of any of the numbers. So I will make 32, which is a multiple of 4, and write it in the red circle." On the bottom part of the page, we have 4 circles of different colors: red, black, blue, and purple, marked as 4, 5, 6, 7, respectively. Page 91. Common multiples. Think of a number. If it is a multiple of 3, write it in the red circle. If it is a multiple of 5, write it in the blue circle. Below this we have 2 circles, a red circle marked 3 and a blue circle marked 5. They are overlapping slightly each other in the center, and that portion has been shaded as purple. Some numbers are multiples of both 3 and 5, so we can say that they are common to both 3 and 5. Think, if you write the multiples common to 3 and 5 in the purple part, then will they still be in both the red and the blue circles? Which is the smallest among these common multiples? Dash. Repeat the game using the numbers 2 and 7. Write the common multiples of 2 and 7. There's a blank box provided below for your answer. Towards the bottom right corner of the page, we have a picture of a boy and a girl who look a little confused. The boy is asking, "Where do I write 15? It is a multiple of both 3 and 5. Page 92. Repeat the game by putting the multiples of 4, 6, and 5 in the circles. We have 3 circles marked as 4, 5, and 6 in different colors: red, blue, and yellow. They are overlapping each other, and the common areas have been marked in different colors. The area overlapped between circle 4 and 6 is marked in orange. The area overlapped between circle 4 and 5 is marked in purple. The area overlapped between circle 6 and 5 is marked in green. And the area overlapped by all 3 circles is marked in gray. What common multiples of 5 and 6 did you write in the green part? What common multiples of 4 and 6 are written in the orange part? In which colored part did you write the common multiples of 4, 6, and 5? What is the smallest common multiple of 4, 6, and 5?
Part 1.
Chapter 5. CIET NCERT presents Audiobook of Mathematics for Class 5 entitled MATHMAGIC 5. This is the Chapter 6.
Part 2.
Page 92. Puzzle. Tamarind seeds. Sunita took some tamarind, that is, imli seeds. She made groups of 5 with them and found that 1 seed was left over. She tried making groups of 6 and groups of 4. Each time 1 seed was left over. What is the smallest number of seeds that Sunita had? On the right side of the page, we see a picture of Sunita with her tamarind or imli seeds trying to create groups of 5, 6 and 4, one after the other. For the teacher, encourage children to try out themselves such activities using seeds, pebbles, etc. Page 93. More tamarind seeds. A Minnie is arranging 12 tamarind seeds in the form of different rectangles. Try to make more rectangles like this using 12 tamarind seeds. How many different rectangles can you make? If there are 15 tamarind seeds, how many rectangles can you make? On the top right corner of the page, we see a picture of a Minnie trying to arrange 12 tamarind seeds in the form of different rectangles. Coloring the grid. Below this, we see a huge grid space and lots of colors all around it. In the grid here, a rectangle made of 20 boxes is drawn. The width of this rectangle is 2 boxes. What is its length? Color a rectangle made of 20 boxes in some other way. Page 94. What is the length and width of the rectangle you colored? In how many ways can you color a rectangle of 20 boxes? Color them all in the grid and write the length and width of each rectangle you have colored. Bangles. There are 18 bangles on the rod. Meena is trying to group them. She can put them in groups of 2, 3, 6, 9 and 18 without any bangle being left. On the right side of the page, we see the picture of Meena along with a boy arranging the bangles in different groups. How many groups will she have if she makes groups of 1 bangle each? Dash. Now complete the table for different numbers of bangles. For each number, see what different groups can be made. On the right side of this, we see a table with 2 columns. Column 1 is for number of bangles. 18, 24, 5, 9, 7, 2, 10, 1, 20, 13 and 21. Column 2 tells us the different groups we can make. For example, the first row, first column number 18 can be put in different groups of 1, 2, 3, 6, 9, 18. The second number 24 and the different groups we can make 1, 2, dash. Rest of the column 2 is empty for your answers. Page 95. Fill the chart. Complete the multiplication chart given here. The chart comprises of sequence of numbers from 1 to 12 going from left to right horizontally and top to bottom vertically. The first cell of this table or chart is a cross. Some numbers are mentioned on the grid spaces like 12, 20, 21, 40, 72, 66. In fact, 12 has been shown at numerous places, showing how we can get the result. Observe the green boxes in the chart. These show how we can get 12 by multiplying different numbers. 12 is equal to 4 multiplied by 3. So, 12 is a multiple of both 4 and 3. 12 is also a multiple of 6 and 2, as well as 12 and 1. We say 1, 2, 3, 4, 6, 12 are factors of 12. On the bottom right corner, we see how 12 can be a result of the multiplication of two numbers, 4 multiplied by 3, 6 multiplied by 2, 1 multiplied by 12. Page 96. What are the factors of 10? Dash. Can you do this from the chart? On the right side, we have a small table with 10 written at the top and the first factors written down below it, like 5 multiplied by 2. Then there is a blank space for your answer. What are the factors of 36? Dash. Find out all the factors of 36 from the multiplication chart. What is the biggest number for which you can find the factors from this chart? What can you do for numbers bigger than that? Common factors. Write the factors of 25 in the red circle and the factors of 35 in the blue circle. There are two circles overlapping each other slightly in the middle. The left one is red, the right one is blue. The area being overlapped is shown in purple color. Which are the factors you have written in the common part, that is, purple, of both circles? These are common factors of 25 and 35. Now, write the factors of 40 in the red circle and 60 in the blue circle. On the bottom left corner of the page, we have a picture of a woman asking, what are the factors written in the common, that is, purple part of the circle? Which is the biggest common factor of 40 and 60? Page 97. Factor tree. Look at the factor tree. Now, can you make another tree like this? We see a factor tree below this with numbers 3, 9, 2, 18, shown as different balls connected by lines with each other. There is another factor tree drawn to the right side of it with all white balls and blank except the bottom one with the number 18 written in it. In how many ways can you draw a factor tree for 24? Draw 3 of them below. There are 3 white rectangle spaces given below with 24 written at the bottom in a ball and the connecting lines drawn for you to continue. Try drawing the factor tree using other numbers also. Tiling problems. 1. There is a garden in Anu's house. In the middle of the garden there is a path. They decided to tile the path using tiles of length 2 feet, 3 feet, and 5 feet. The mason tiled the first row with 2 feet tiles, the second row with 3 feet tiles, and the third row with 5 feet tiles. The mason has not cut any of the tiles. Then what is the shortest length of the path? On the bottom right side of the page, we see a mason holding a tile. He has already laid some of the tiles in the patterns mentioned just now. Page 98. 2. Manoj has made a new house. He wants to lay tiles on the floor. The size of the room is 9 feet by 12 feet. In the market, there are 3 kinds of square tiles. 1 foot by 1 foot, 2 feet by 2 feet, and 3 feet by 3 feet. Which size of tile should he buy for his room so that he can lay it without cutting? To the left of this question, we see a picture of Manoj holding some tiles. 3. We have a picture in which we see 3 different houses marked as Rani's house, Geetha's house, and Nasima's house. 3 girls are standing outside the houses at a distance, talking to each other. There is a road a little far off from the houses, and all the houses are at 90 feet distance from the road, shown by 3 different lines. Rani, Geetha and Nasima live near each other. The distance from their houses to the road is 90 feet. They decided to tile the path to the road. They all bought tiles of different designs and length. Rani bought the shortest tile, Geetha bought the middle-sized one, and Nasima bought the longest one. If they could tile the path without cutting any of the tiles, what is the size of the tiles each has bought? Suggest 3 different solutions. Explain how you get this answer. For the teacher, it will be useful to have a discussion about a foot and how we use it often to talk about our own heights. Children can use their centimeters scale to get an idea about how long a foot is.
Part 2.